Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 3 till 4 in the afternoon, and we are now in our 7th week of our 9-week course. At this point, you should definitely be submitting work if you haven't already, as we only have 3 more weeks left of our class, and then everything needs to be done before that so you can do your culminating activity. So the key questions are the ones that are listed at the end of each lesson. So please do all of them. Some of them are check your understanding questions, some of them are activities at the end of each chapter, and most are review questions at the end of each chapter. So look at that list and do the appropriate questions. Please show all of your work explaining all of your thoughts and your thinking. This way I can truly understand what it is that you understand. So, and then also make sure that you are answering the question that is actually being asked, opposed to just talking on the topic. You can do it by hand or electronically. Feel free to write in your workbook if that works for you. I'm not attached. It is a small space, so I would be surprised if you have enough room, but if you're able to fit your ideas in there in a way that is full sentences that explain your thoughts completely and is clear, that is totally fine with me. You can also type up your work in electronically. Using Word or Google Doc files are the ones that are easiest for me to open. So if you use those, that would be great. Everyone has access to Google Docs through their NNEC email address. So I can support you to get access to that if you need it. If you are going to use a different program, I'm sure that it's fine. Just touch base with me so that I can make sure that I can open your files. We can do a trial version or something. There are 3 different methods for submitting your work. If you are sending it electronically, so you can scan your written out work if you have any, by using a smart device, either the iPhone Notes app or the Android Google Drive app. Both have scan functions that are fairly straightforward. If you want support, I can help you do that. If you prefer to just send pictures, that can work too. I don't mind taking pictures. They're just larger files and not necessarily as convenient to send as one file, but it's fine. I can deal with it if that's what works best for you. Then you can send it through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can also send it to me through Facebook Messenger at bslatewasa. The second method is drop your work off into Lookout. We have an outdoor mailbox at our location at 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put your work in there at any time. The third method is to hand your work into your DEC. Then your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslatewasa. So friend me on Facebook or subscribe to my YouTube channel and you'll get notifications every time I upload one of our lessons. All of our classes are recorded and I upload them within a few days of airing. Try to do it as fast as I can. Sometimes things happen. All of our lessons are found under a playlist called SVN3E. Also within that playlist, there is another playlist that is called supplementary lesson or supplementary videos, I guess. And that is where I've linked all of our videos that I've shared in our class. So that is a good place to access the original material. And if you just want to watch it again. Science is a very visual subject, so I strongly encourage you to tap into not just the audio, listening to me on the radio, but also seeing the visuals that I create. include a lot of diagrams and images and videos as much as I can to really connect to the various parts of our brains. So if you can't join me live through Zoom, which you're always welcome to do, even if you just want to watch and not talk to me, that is totally fine. Or if you can not access them on YouTube, the replays, let me know and I can send you a copy of the recordings so you still have access to them and set yourself up for the most success. If you have any questions or concerns, please contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. My phone at the office is 807-737-1488, extension 2209. Or you can also call me toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 4 p.m., though I teach the first hour and the last hour of the day. So those are not the best times to get a hold of me, but the rest of the day, I'm generally at my desk. If you miss me, I will try to get back to you as soon as I can. All right, I think it's important for me to position myself within the context of education in our society to show how education has shaped me and how our society has shaped me, and therefore how that plays on how I teach. So I share my positionality at the beginning of every class. I have white settler ancestry. I am a white person with white privilege, and this shapes how I'm treated in the world. This shapes how I have learned and how education has been presented to me and where I have found belonging and a sense of self. So this means that I may miss things that other folks do not. And I work hard to acknowledge my privilege and to work against that, disrupt that cycle, though it is something that is so deeply ingrained in all of us that it is definitely a challenge to do 100% all of the time. So I'm working on it. I live in Northwestern Ontario on the traditional territory of the Anishinaabe people, and I am working towards learning from the people and the culture in my area. I respect and honor them and the knowledge keepers of this area. So I try to integrate as much of our local knowledge into our course as I can in order to represent the people who live in this area and the people whose knowledge has often been ignored and is definitely worthwhile to hear. This is my first time teaching the course, however, so I have lots to learn and unlearn. It is a process. It will always be a process. I will likely never get it 100% correct, but I am, again, working to integrate some social justice and acknowledgement within our course in order to represent the people who and teach the people who are actually taking this course. And even so, and anyone really should know these histories and these current present experiences that often are ignored. Our textbook, however, is Eurocentric. It is older, and it is focused on the experiences of white people in my perspective. Both the scientists and the communities that it talks about are often white communities, and this ignores the Inuit, Indigenous, and Métis knowledges, as well as their experiences when we don't recognize the knowledge keepers from these communities, nor do we recognize the successes and struggles of Indigenous, Inuit, and Métis experiences that are both historical but also current. This is really problematic as it erases a large chunk of the reality here in Canada. So I work to integrate as much as I can, or stepping stones I'm starting to. I will continue to work to integrate more as I go. If you have any suggestions or feedback for me, please feel free to reach out and share that so that I can improve and do better. All right, so we are wrapping up Unit 5 today, which is making work safe and buildings energy efficient. Buildings shelter us from the weather and allow us to carry out our tasks in safety and comfort. We work, play, learn, shop, live, worship, sleep, and exercise in buildings. Because we use them so much, it's important that our buildings are not only safe, but also environmentally sustainable. To achieve this goal, we need to make them energy efficient. So that is our focus on today's lesson. So today's lesson is lesson 18, making buildings energy efficient. So our learning goals are that at the end of this lesson, you'll be able to describe how energy is commonly used in the home. You'll be able to describe how homes may be constructed with economy and energy in mind. And you'll be able to describe how to identify energy efficient appliances. So you know you've met learning goals because you can explain methods of designing energy efficient buildings. You can explain how to make older buildings energy efficient, and you know the different appliances, motors, and water heaters that save energy. All right, so let's dive right in, how we use energy in our buildings. So our buildings consume a lot of energy. According to the National Research Council, residential and commercial buildings account for over 36% of the energy used in Canada. We use this energy to heat them in the colder months and cool them in the warmer months. We use it to heat water and run appliances. We also use it to operate machines, lights, and electronic and other devices. So here is some pie graphs that are taken from your workbook that shows how we use energy in our homes and our commercial buildings. So in our homes, you can see that space cooling. So I don't know what this big chunk is, and that seems very strange that it doesn't have any sort of indicator on it, which is odd. So I don't know if that's heating our homes, but cooling our homes is a small portion, but we do it. And lighting is a small portion, but we do it. Then appliances and water heating are two larger chunks, almost a third, maybe they're a sixth each. But like 2/3 almost is this big chunk, which I would assume is heating our homes, because in Canada, we have to heat our homes a lot. It's cold here. Then in commercial buildings, there's more chunk in space cooling, as that makes sense that in buildings with lots of computers, lots of machines, they have to be cooled more. And then still a chunk in what I would assume would be heating. Lighting is a large chunk in commercial buildings. Water heating is a much smaller chunk. We don't do in the majority of our commercial buildings, we're not using hot water to the same extent, and appliances are a small chunk. But then motors exist on this list, opposed to the ones that is the home one. So that just sort of gives you a little bit of an idea of how we use our energy in both our homes and many of our commercial places. So the greatest need for energy in residential buildings is for space heating and cooling. So on average, about 63% of the energy used in a typical Canadian home goes towards space heating and cooling. Another 18% goes for water heating. In commercial buildings, almost 50% is used for space heating and cooling. Some 36% on average is used for lighting. There are ways to significantly reduce the amounts of energy needed for these. We can design more energy efficient buildings and upgrade older ones by replacing old lighting, water heaters, and other appliances with more energy efficient ones. The less energy we use, the less it costs us, and the less demand we place on our environment. As a result, we also leave more resources for the generations that follow us. So even if we are still using a large portion of energy, even if we're still using it in these ratios, if we are doing it more efficiently overall, that means that we are saving more electricity or more energy overall. So how can we design energy efficient buildings? So the outside walls, roofs, doors, and basement floor make up a building's envelope, is what it's called. It's called this because this surface wraps around everything inside the building. The envelope keeps the building's contents, including people, protected from the weather. It also forms a barrier against heat loss when the furnace is on and heat gain in the summer when the air conditioning is on. If this barrier fails, the energy loss through its parts can be large. So here is a picture that shows the envelope. So this red line that goes around the outside of the building, you want that to be sealed in order to keep heat in when you are heating your home, and in order to keep heat out when you want your home to be cool. So this envelope is really, really important. I've definitely lived in homes where that is not super sealed, and you can feel the cold air coming in through doors or around windows, and that having a really big impact on the well-being of my household, just because the envelope wasn't sealed and wasn't really strong. So how do we trap air in the envelope? You've heard people tell others to keep the cold air from getting in during the winter. So maybe you've heard someone standing at the door and saying, hey, you're letting the cold air in. But really, the reason our buildings get cold must be heated is the opposite. Heat moves towards cold, not the other way around. So really what's happening is you're letting the heat out. If you're standing in the winter with the door open, then you're letting the heat out opposed to letting the cold in. Modern buildings designers know where and how heat escapes through the envelope. So during summer, heat from outside gets into our buildings through the same routes. So here you can see this diagram shows different places where the heat is lost from a badly insulated house. So the house that I was talking about was definitely badly insulated and sealed. So 25% goes up through the roof if your roof is not insulated well. Houses that have in the winter don't have any snow on them because it's all melted off means that there's a lot of heat escaping and through the roof, and that's melting the snow and letting it fall off. So you don't want to have, yes, you don't want to have a lot of snow on your roof. That is not safe, but having it all just come off naturally means a lot of heat is escaping through your roof. And 35% escapes through your exterior, your outside walls. 25% through doors and windows. So if how well those are sealed can really release a lot of heat. And then up to 15% through the ground floor is where heat going into the ground is another way that we lose heat from our envelope. So today's buildings designs called for tightly sealed envelopes that trap lots of air. Trapped air slows heat movement. The more air trapped, the longer it takes for heat to move through the envelope outside in winter and inside in summer. Because heat movement takes longer, much of the energy that would otherwise be used on heating and cooling is saved. To trap air, workers seal the outside of the envelope against drafts. They do this by using caulking and foam around wood and masonry joints, windows, and doors. They also do this around electrical, plumbing, and other utility services that go through the envelope. They then fill envelope cavities in the roof and walls with insulation. The insulation contains lots of air pockets that trap air. More insulation means more trapped air and greater energy savings. They cover the inside of the envelope with a polyethylene vapor barrier. It prevents moisture from inside the house from getting into the envelope. Then they cover the vapor barrier with an inside wall surface like drywall. So you have like a sandwich where you have your outer wall, you have your insulation, outer wall, your insulation, your vapor barrier, which keeps the moisture from getting your insulation all moldy, and then your drywall or whatever siding for inside the houses your walls are. Oh, here is that exactly what I just did. Sorry, I felt like there was a picture, but then I forgot. So this is goes in reverse of what I was thinking about before. So here is your exterior wall. Out here is like your siding, right? Your aluminum siding. Then you have your plywood, which is your first, keeps the insulation dry, helps keep it dry. Here's your insulation, which captures those air pockets that you trap air. Then you have your vapor barrier here, and then you have your drywall. And this all happens in here. This is the saying suggesting in 213 millimeters. So 21 centimeters of space is all of that is packed into to keep your home warm. So in the basement, rigid insulation is placed on the surface over which the concrete is poured. So basement walls are typically also insulated with rigid insulation fixed to their outside surfaces. So rigid insulation is kind of looks like styrofoam. It's hard like styrofoam, and it's put into the floor. Then concrete being poured over it means that there's less heat being lost to the earth. Then we have energy efficient windows and doors, trap air or gas like argon, which also slows down heat movement. So that is, so that means that there's less heat being released through the windows and doors. So here you can see, we've talked about this before. In this window, we have, it's a double glazed window. It's got this space in between the two panes, and that traps air, or there can be gas like argon in it. And it means that the heat doesn't get out as much. There's maybe a little bit of it, but it doesn't get out as much air. That gets reflected back into your home. And that also means that it doesn't come in the summer. Doesn't come in, as much heat doesn't come into your home, and therefore it doesn't get as hot. So how can we design better envelopes? So buildings built as described can save as much as 30% on heating and cooling costs. However, alternative ways of designing and constructing buildings can do better. So even just, so all those ways of sealing that we've talked about are good. Of having proper insulation, having a thick barrier, making sure your ceiling, your roof, and your floor are insulated as well is good, but there's other ways that we can do even better. So one example is the straw bale buildings that are built using dry straw bales. The bales replace much of the insulation and framing used in conventional buildings. The fire-resistant bales have no food value to attract pests. Workers stack them to construct walls. They stucco their outside surfaces and then plaster them inside. This procedure protects the bales from moisture and trap air. The walls for such buildings are thicker than 450 millimeters or 500 to 80 millimeters based on the width of the straw alone. So thinking about, remember that was 213 was the last wall. That is the current sort of wall. So this is like twice to almost 3 times the amount, the thickness of the walls. The straw bale building costs about the same to build as a regular one. However, heating and cooling costs can be up to 50% less. So that's saving a lot. Here are some pictures of straw bale houses. So you can see it has some post framing, and then the hay bales are stuck in between. And that is your insulation. You just got a thick straw wall. Then here, this picture shows you them stuccoing the outside. So putting a plaster, a mud-like plaster that will dry on the outside that protects it and makes it not look like it is hay or straw, but protects it from the elements and the moisture so that it doesn't get moldy. So now you can do the key questions on page 146. Check your understanding 1 through 3. So that's designing more efficient buildings. But what else can we do? So we can use energy efficient appliances, motors, and water heaters in our buildings. So remember that appliances and water heaters are fairly significant pieces of how we use energy in our homes, and they're less used in our commercial buildings, but motors are also significantly used in our commercial buildings. So this is all useful for both our homes and our buildings. But overall, today's commercial and residential appliances, motors, and water heaters do use far less energy than before. Modern refrigerators and air conditioners use up to 50% less energy than those made 20 years ago. Appliances for both residential and commercial uses, such as ovens, dishwashers, ice machines, fryers, and griddles, may be Energy Star rated, and that means that they use less energy. Electric motor drive, such things as fans, saws, drills, conveyor belts, and mixers. Specifying high efficient motors can be commercial buildings may cost more. However, the motor can pay for themselves in energy savings in about 2 years, and then you're just saving. Homes use a lot of energy for water heating. Designing homes to use tankless hot water heaters can reduce the amount by up to 75% for small households. Tankless hot water heaters also typically last twice as long as standard tanks and take up less space. And then another option is solar hot water systems. In Ontario, these systems can save up to 60% on water heating costs. Although many times more expensive than conventional water heating systems, they last for longer. They also pay for themselves in energy savings in about 7 years. After that, the hot water they supply is essentially free. So these things, many of these things that we've talked about in the past and we're talking about today are a big investment up front. They cost a lot up front, and so that feels like it's a big hit. But over time, they're saving you money so that you're paying off that amount that you invested at the beginning, and then you end up saving money that you don't have to reinvest later on. So it is something to just remember that these things, yes, do seem really expensive at the beginning, definitely, but they end up costing you less in the long run. And so it's about the long game opposed to just the short game. So we can talk about R2000 homes. A Canadian program, R2000, is designed to create energy efficient, environmentally responsible homes. Launched in 1981, R2000 has since been adopted around the world. Homes built to R2000 standards typically use 30% less energy overall than homes built to other building code standards. The R2000 standards are performance-based. This means that homes must meet targets for such things as energy efficiency, ventilation, indoor air quality, and limited need for water and other natural resources. The target levels vary according to home locations. Qualifying homes are awarded R2000 certificates. So here you can see that if we're comparing an R2000 home and a conventional home, yes, an R2000 home costs a little bit more than a conventional home. But the benefits, you can see that you have increased resale value, increased comfort, healthier indoor air, and energy savings. So you get so many benefits from having an R2000 home, even though it does cost you financially a bit more than a conventional home. But if you think about it in terms of a conventional home, it saves you money, but it costs you all of these other things, which has an impact in the long run. And then we have smart homes. So smart homes connect devices that work on electricity in a network. Smart home owners can program and control this network via a control panel, computer, or remote device. Separate programs can be set for such things as lighting, heating, air conditioning, home theater, and security systems. Although smart homes can be costly, they can also yield significant energy savings. For example, in combination with motion sensors, light can be set to turn on when people enter a room and to turn off when they leave. Heating and air conditioning can be set to turn down at night or when people are away, and to turn up just before they wake or return. Refrigerators and water heaters can be programmed to work with maximum efficiency. So your house being smart and doing some of the work for you means that people can't be like, oh, I just keep forgetting to turn the lights off or whatever. Your house, programming your house to be able to do some of those things can really end up saving you energy in the long run, which helps financially. And we have zero energy buildings. So so-called zero energy buildings or net zero energy homes are designed to sustainably produce as much energy in a year as they consume. That's why they're called zero energy, because they have to take energy. We rely on energy, but they also produce energy, which means that they aren't taking external energy. So they couple energy savings techniques like those used in R2000 homes with alternative energy sources. The alternate energy may come from solar, passive and active, wind, geothermal, biofuel, and small-scale hydro installations. One or more sources may be used. Zero energy buildings typically also rely on smart home networks. Several buildings may be linked to share alternative energy sources. Although costly and experimental to date, zero energy buildings hold much promise. So this is a great idea, though we're still learning about it. It isn't something that has been perfected yet and been able to be mass marketed in order to be available to large portions of people, as they are really expensive and therefore inaccessible for most of us. So here is a picture of a net zero energy home. So you can see that you have your solar water heater. So solar panels that are going to heat your water. You have your solar energy panels. So panels that are collecting solar to just have lights and electricity within your home. Passive solar shading over glazing. So that's here is that the summer sun doesn't get it into your home. So that means you know it's cool, you don't have air conditioning, but the winter sun is at a lower angle. And so that means that it gets warm there. So that's a passive solar gain. Collecting rainwater that can then be cycled into your system. Geothermal system, which is tapping into the renewable energy source of geothermal and heating your home like that. And drain water heat exchange, so water being cycled back through from your system. So this is just one example of what a zero energy building might look like. Okay, so now you can answer the key questions on page 150. Check your understanding questions 1 and 2. And now we're going to talk about retrofitting older buildings, which has been more my experience, as I'm not buying a new building. I'm not creating a new building. I'm trying to figure out how to deal with an old one. So in order to do that, old buildings were usually built when energy was cheap. By today's standards, they are usually big energy wasters. However, they can be upgraded to make them more energy efficient. Upgrading services, energy efficiency, fixtures, and other features of older buildings is called retrofitting. The cheapest energy efficiency upgrade is to caulk and weather strip your windows, doors, and other sources of leaks to stop drafts. So you're sealing up that envelope by caulking it or putting in weather stripping to help keep that envelope strong. A more expensive option that will pay for itself in time is to upgrade to energy efficient windows and doors. So though it costs up more, you will save more in the long run. Again, all of this, though it is hard, it's an upfront investment for the long run. Another solution is to upgrade the building's insulation. Loose insulation can be cheaply blown into attics and existing walls with little inconvenience. If the walls are to be torn down as part of a larger renovation, the envelope's cavity space can often be increased. It can then insulate with more efficient insulation, such as fiberglass bats or rigid foam boards. So if you're going to renovate the whole thing, keep that in mind in terms of how you are going to insulate and how you can improve your insulation as you go. Basement walls can be framed on the inside and insulated and finished. This requires digging up the foundation walls. Still, a third option is to have expandable spray foam blown in above the steel plate inside the basement and also between the joists or rafters of the attic and on the basement walls. The foam dries into a dense sheet that traps lots of air. Although expensive, this method is often best for old buildings because it fills up every crevice and provides superior insulation. Upgrading to fluorescent or light emitting diode LED lamps can save 75% or more on lighting costs. We've talked about that before. Upgrading to high efficiency furnitures and appliances will also yield big savings, as will converting to tankless hot water systems. So again, all of these things help for the savings in the long run, but are generally a large investment at the beginning. Then you can have the most expensive to upgrade are to the alternative energy sources. But there are government incentive and policies and energy savings in the long run that make these choices attractive. They encourage more people to buy them. That's the point of the government incentives. So the money is to encourage companies to design and build more products at lower cost to meet demand. In this way, energy efficient choices gradually become more affordable. Therefore, they can be more accessible to a wider population of people. All right, and that is our lesson for today. So that's lesson number 18 and making buildings energy efficient. So we talked about designing energy efficient buildings and trapping air in the envelope and designing better envelopes. We talked about energy efficient appliances, motorhomes, and heaters. So that all contribute to R2000, smart homes, or zero energy buildings. And we talked about retrofitting older buildings for energy efficiency, which include your windows, your lights, your appliances, your insulation, alternative energy solutions, with government incentives. So hopefully now you can explain methods of designing energy efficient buildings. You can explain how to make older buildings energy efficient And you know the different appliances, motors, and heaters that save energy. So for this lesson, you have an activity to do, activity 5.3 on page 152. So this is looking at the energy consumption in your home. So the purpose of this, so this is like a bit of a mini lab. The purpose is to determine the energy consumption of a home by reading, interpreting electrical meter readings and calculating the cost of the energy. So you should have a hydro or an electrical thing on the exterior of your house. The cost of electrical energy is based on price per kilowatt hour, which we talked about before. The electrical energy usage is measured using a meter that is attached to the wiring of a house or building. If you have an older meter in Ontario, there is a set rate for each kilowatt hour. If you have a new or a smart meter, the price per kilowatt hour depends on the time of day you use the electrical energy, which is what everything has been converted to these days now, right? Remember this, your book is old. Each month, your home's electrical bill is based on the meter reading of the amount of electrical energy in kilowatt hours used in the previous month multiplied by the cost of a kilowatt hour. The cost of kilowatt hours in Ontario varies from about 4 cents to about 9 cents. So for this activity, assume your kilowatt hours cost about 7 cents. I don't know what that is currently. I didn't look it up. I forgot to look it up to see what the current price is, but still just use 7 cents. That is fine. So your procedure. The following table lists various household appliances and their estimated average monthly use. So your air conditioner is about, monthly use is about 900 kilowatt hours. Your blender is 0.8, clock 2.2, clothes dryers 85.0, clothes washer 8.7, coffee maker 4.7, computer 27.4, corn popper 1.0, curling iron 7.2, dishwasher 5.0, DVD player 2.5, entertainment system 15, freezer 147.0, frying pan 12.0, garage door opener 1.1, iron 5.0, jacuzzi 140, light bulb, one light bulb is 7.7 per month, microwave oven 16.5, a mixer, a hand mixer is 1.0, radio 7.2, a range oven is 21.3, a refrigerator is 150.0, satellite dish is 66.0, television is 36.6, toaster 4.2, vacuum cleaner 9.4, and water heater 400.5. So on this list, you have to identify which of these appliances you have in your home. So just go through and maybe check them off or cross the ones off that you don't have. So I don't have a garage door opener. I'm going to cross that off. I never use an iron, so I'm going to cross that off. The jacuzzi, nope, I cross that off. So you just go through the things I have. I don't have an air conditioner, cross it off. I have a blender, I would put a check mark. I use it by a blender. I have a clock, check mark, I use that. Clothes dryer, yes, check mark. Clothes washer, check mark. So you would go through what makes sense for you, for your household. Then using the numbers in this table, what is the total monthly cost of the running appliances that you have in your home? So you add up all the ones that you do have, ignoring the ones that you don't have. Then what is the yearly cost of running the appliances in your home? So you can figure out what it is monthly. To figure out the yearly, you're going to times it by 12. Then you're going to decide which of your appliances are the most expensive to run. So for me, that's going to be the water heater. I do have a water heater. Describe how you could reduce the use of that appliance. Yeah, I don't know about that one. Which appliances could you do without in your home? So are there things that you did check off that you already said that you have that you could not use? How much would you save if you did not use those appliances? If your home had all the appliances listed in the table above, how much would it cost to run these appliances for the year? So now assuming that you have everything, add them all up to figure out how much it would cost for the year. Remember, these are monthly uses still. So then conclude in a paragraph, write a conclusion that summarizes what you learned in this activity. Your conclusion should also describe some ways you could save money by reducing your electrical bill. So that is the lab that you need to do in addition to the other questions. This is something you need to think about a little bit, and it's more of a thinking and inquiry kind of situation opposed to just answering questions directly. And then you still have your review questions on 153, a number 1 through 14, which are just answering these questions. All right, so thank you so much for joining me. That is wrapping up Unit 5. So now we are starting Unit 6 in our next lesson. And we have just Unit 6 and 7 left. So we only have a few more new lessons with new material. Do remember that all of your work needs to be in by the end of, by June 10th. You need to have all of your coursework in by June 10th, as well as a culminating activity. So you need to get all of your work in before June 10th so that I can give you a culminating activity in order for you to get the credit. You need to get your coursework, but also do the culminating activity. That's another element that you don't have yet. So if you're just like, oh, I'm good, I've almost done, then I can just hand it in on June 10th. Know that you will be then missing something that is worth 30% of your mark. So it's important for you to get everything in before that so that you can get your final project done as well. And also just remember, I have like 60 students or so across all of my classes. If everybody handed out all of the work in on June 10th, there'd be no way for me to actually mark it all in time for the end of the year. So if you want your work to be marked, get it in sooner than later. And if you want it back so that you can do your culminating activity, get it in as fast as possible. If we're just getting down to the crunch time where we only have 3 more weeks, and then our class will be wrapped up. Also a reminder that we'll just have 2 weeks of new material this week and next week. And then in our 9th week, we'll be doing a review of the whole course to remember, what we have done in preparation for your culminating to help you do your culminating. So having all of your other work done by the end of week 8, taught all of the material by the end of week 8, means that then you can spend week 9 reviewing and doing your culminating activity all together. If you have any questions or concerns, please reach out and contact me. Calling me at the office, you can do that at 807-737-1488, extension 2209. You can call toll free as well at 1-800-667-3703. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can also connect with me through Facebook at B/Slate Wahsa, and you can watch our videos at YouTube, also at B/Slate Wahsa. My office hours for this term are Monday through Friday, 9 a.m. to 4 p.m. So please reach out if you want to connect with me during those times. I'm fairly good at getting back quickly through email and Facebook. If I miss you on the phone, I will get back to you as soon as I can. I will get back to you quickly. Though if I'm in class or busy, I might not be able to answer my phone right away. Thank you so much for joining me today. I hope this was a useful lesson. Have a lovely day. Mugach.